to discuss all this.
So what did we talk about? We talked about the moon. We talked about
Well, three
protons,
papers on magnetic anomalies.
magnetic anomalies. We
Right.
talked about sodium and exosphere. We talked about albedo protons. And we talked about ion cyclotron waves. So man, take your pick. Dana, you get to get the cube of power.
So I guess the way this works, the authors are supposed to come up.
Oh no, this is a free-for-all.
Oh, free-for-all discussion, okay.
So I'm wondering if any of the speakers who talked about magnetic anomalies, and I guess anybody else who didn't talk or in the audience, if anybody disagrees with the statement that swirls are caused by a change in the flux of ions to the surface of the moon.
Well, I'm not answering that question.
So I'll answer real quick and I'll get it back to you. I think it's not only the flux, but it's the energy distribution that they hit the moon. They have to be energetic enough to do something when they hit the moon. And so I know that Jan talked about this, I've talked about it before, that even if the protons aren't fully reflected before they hit the surface, if they're decelerated enough, then they don't play a role in almost anything. So.
There may be one other factor, and I think it was in Brent Denevit's paper talking about if the surface itself is iron enriched, then you could get, it almost acts like an extra response, which might account for the swirls in some locations, but in more iron, in regions where there's less iron, it doesn't seem to show up. Hopefully I don't know if she's here, hopefully I didn't ruin her. So, oh good, so then I can, right. But I read that and I was kind of surprised. So it suggests that there was a surface ingredient required as well. And that the swirl seemed to be located, and I'm just located in places where they're in the iron-enriched region where there was a suppression. So it almost was like I want to say like a fluorescent or so. You know, it was almost like iron seemed to be an issue.
But so that's like a second requirement that you still need that requirement of the change in the ion flux to the surface.
Right, so that would be, and then the surface itself has to be palatable with maybe the iron. But I just briefly read the paper a while ago, and anyway, it's worth looking at.
Okay. Any other proton responses? Okay, Rosemary.
Okay, my question is for Jody. Do you have any idea why you get an effect between dawn and dusk, and if I understood you correctly, not very much effect between the equator and the pole?
In other words, you're asking why is the yield contrast, is it on? It is? Okay. Why is yield contrast so much greater morning, evening versus pole to equator?
Yes.
Yeah. Well, we don't know except that, I mean, the first blush is that maybe this whole thing, if this is real, if this whole thing is actually mostly just a diurnal effect, and the fact that there's also a slight latitudinal trend is secondary. Yeah, I mean, it's a 38% contrast right now, a 35% contrast at least between dawn and dusk, and that's averaged over all longitudes. We haven't even started to look at what happens only near the pole morning, evening, what happens at the equator morning, evening. We haven't even looked at that yet.
So would that suggest that the hydrogen-bearing stuff at the poles is more patchy, and the morning, evening is widely distributed? So as an average, you get a bigger contrast.
Well, just based on what we have so far, I can't answer that, especially when you get towards the pole. I mean, if you want to talk patchy, if you're thinking individual craters, yeah, I don't know if we have the resolution for that yet. Yeah.
Other discussion? More discussion. Okay.
Just kind of along those lines, Jody, I'm wondering if you would see were to split it into latitudes, if you'd see less variation at the poles morning to night than you would at the equator. That would make sense, given water stability and the volatile question you don't want to have to answer.
Certainly, if it turns out that it's happening mostly at one set of latitudes or the other, that'll tell us a lot about what's going on. Exactly. So we need to do that. Okay. Yeah, yeah.
Are you able to get your field of view small enough to do that, or how would you do that?
What it's a question of is just getting enough data. Our detection rate, after we've removed all the spurious events and subtracted the noise and whatnot, our detection rate is pretty low. So it's just a question of how much longer LRO stays in orbit and we collect those beep, 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 those particles one at a time. That's what it comes down to, yeah.
Thanks.
More discussion? I see you. Oh, you're scratching your head. All right, okay. No more discussion? Peter?
Yeah. I'm very curious. Sorry. Yeah, I'm interested in presentations about magnetic anomalies, and for example, Bill showed or mentioned about Moonrise mission that could take sample from the moon to verify the mechanisms and so on. Wondering if that would be enough to verify the swirl formation hypothesis that people have come up, or there would be need for other types of surface measurements, especially perhaps to verify magnetic field on the surface. I know Ian has a big plan to use CubeSats, or many of them, go over the region, but just wonder if there's anything that people can do on the surface except to take samples.
Right. I believe there are concepts out there to do that. And in fact, I think Dave Blewett has done a presentation, I believe at LPSC, about getting into swirls with plasma packages. And, it would be great if Moonrise actually included a plasma package, a magnetoplasma package. But really getting the sample back might actually tell us a lot about how it's weathered, why it might be different. So it's really the combination of both.
Yeah. And also, just for the surface measurement, is it enough to just have a single station, or because it seems like it could be a wide variety of field distributions near the area. So
well, Moonrise is going to the South Pole Lake and Basin to, it's like solar system history. Look, they're answering a big question. So if they were nice enough, and so this is almost like a plea if they were here, like if you by chance happen to scrape the top, just toss it in, so because it's not their prime objective. So the idea that it would be great if we could justify multiple stations, that'd be awesome. But, in some sense, I can't imagine it happening, and, given the ocean worlds and the quest for life and all that kind of thing, that they would devote multiple, So if someone's going for something else, maybe we might ask them to just take a little off the top for us,
Okay, any more discussion?
Just curious, how deep would you take that? A millimeter, micron?
Well, something like a millimeter. In fact, they were going to go deeper. And when I talked to a couple folks on the team, they said, okay, we might make a special, make it a point to collect off the top. So they were going to go look down a little further. So, but of course, Moonrise, New Frontiers, and how it goes, 1 out of 13 chance, and so it's a lottery ticket.
Okay, any more discussion? Okay, then I think we have a small break to transition to the other room, and the plenary session starts at 3 p.m. with Alan Stern. So, thank you all for attending.
Good job. You did, everyone asked my questions up